8.8 looks in more detail at something we've looked at a little bit, inequalities. So we've talked about inequalities like this. X is less than 2. So let's start out here with some different notations. First of all, it says graph on a number line. So to do that, I draw in a horizontal line, represents values of x, and then I indicate the value, there's 2. So I want to shade the region where x is less than 2. So that's this direction. Okay? Then here's what we're going to do. So you see how here, this is a strict inequality, as in it's strictly less than. Versus down here, it's a less than or equal. So when I have a strictly less than, I use parentheses, versus when the endpoint's included, I use a bracket. So that means here at my endpoint, I'm going to indicate with a parentheses that this inequality does not include the endpoint. Okay. So there's my number line. And then let's see what else it says. It says write in set builder and interval notation. Okay. Okay, so here's how I would do that. I would say the set of all the x's where. So that's like a curly brace, like so. And then I have the x, and then I use a vertical bar, that means where. And then I write whatever the condition is here. So in this case, that's just x is less than 2. Okay, so how do I read that? The set of all the x's where x is less than 2. Then I still need to write my interval notation. So the interval notation, I really look at the number line. So I say, how far left does this go? It goes all the way to negative infinity, right? And then I put a comma. And then how far right does it go? It goes all the way to 2. Okay, so what I do here, I put the smaller number on the left, the bigger number on the right. Then I indicate with brackets or parentheses. So actually both of these get parentheses. So infinity, since it's not actually like a number I can actually achieve, it always gets a parentheses as opposed to a bracket. Because I'm never actually going to reach infinity. I can always go one bigger or one smaller. Okay, shall we try another one here? Okay, here's -1. X is less than or equal, so I shade this way. Now remember, if it's an or equal, it gets a bracket. Then let me try writing in these other notations. So I say the set of all the x's where x is less than or equal to -1. Starting on the left, I go from negative infinity to -1. Infinities always get a parentheses. This one includes -1, so I use the bracket. Okay, so x is greater than 4. Parentheses, because the 4 is not included. So I'd say the set of all the x's where x is greater than 4. Or I'd say 4 to infinity. X is greater than or equal to 0. Bracket, because 0 is included. Set builder, set of all the x's where x is greater or equal to 0. Interval notation starts at 0, goes to infinity. Oh, here's something different. These are kind of cool. These guys are called compound inequalities. That one and that one. So these guys have 3 parts. In other words, the x, or the variable, is stuck in between 2 values. So this guy says the x is in between -2 and 1. Okay, the -2 is included. It's a bracket. The 1 is not included. It gets a parentheses. Okay. So then how do I write the set builder notation? Set of all the x's where -2 is less than or equal to x is less than 1. The interval notation would be -2 to 1. Let's try this next compound inequality. It's going to be similar. So the x is in between 5 and 6. Neither of those ends are included, so they both get parentheses. So the set of all the x's, where x is in between 5 and 6, interval notation, 5, 6, both parentheses. So we can solve inequalities. We basically solve these like equations. So solve like an equation, like as if there were just an equals. There's just one thing you have to remember. So if we multiply or divide by a negative, we have to flip the inequality. So that's the only thing we really have to remember that's different about inequalities versus equations. So in other words, I would solve this the same as I would solve an equation. So I'd subtract the 1. Oops, I want to keep that inequality sign. And then I divide by 3. Now I'm dividing by a positive number. So in that case, I don't have to flip anything. So x is less than or equal to 5. So then I can write my solution. In those 3 different ways. There's 5. Let's see, less than or equal, shading this way. 5 would get a bracket because this sign is inclusive. So here I'm writing out my solution. I have my number line. I could write my set builder. I could write my interval notation. So I might be asked to write all 3 of those notations, or it depends on the problem which notation I'm asked to write, but I should know all 3. Okay, how to start this one? Let's see, subtract 1. Okay, this one, look, I have to divide by -2. So remember, when I divide or multiply by a negative, don't forget you have to flip the inequality. Okay, so now I have x is less than -1. So now I can write out my solution. Okay, so I'd be shading this way. Strictly less than, so it's a parentheses. Set of all the x's where x is less than -1, negative infinity to -1. There's my solution written in all 3 notations. Okay, what about number 3? Let's see. So here I actually have some like terms to combine. Let me start by subtracting the x's then. And then add the 2. Okay, and then all I have to do, write my solutions out, my number line, my set builder, my interval notation. Okay, let's see. I would start this one by distributing. So 8 minus 8 plus 4x greater than -2x. So that negative distributes. Remember, that changes both signs. So the 8s actually looks like they cancel. Now I have like terms. So let me add the 2x. Divide by 6. Zero divided by 6 is 0. Now let me write out my solution. Number line, set builder, interval. Not too bad. How to start this one? I could distribute the 1/3, or I kind of prefer to get rid of fractions if I can. So what if instead I multiply both sides by 3? So I'm multiplying by a positive. So I don't have to flip the sign. And so this 3 cancels with that 3. So notice how I don't multiply twice. These two things are already multiplying. So when I distribute that 3 to this factor, that's already affecting this factor. So now I start looking at like terms. So maybe subtract the x. Subtract the 12. And divide by 8. Let's see, 14 over 8, 7 over 4. Let's see, negative 7, 4, so I don't know. I'll put 0 here. Let's see how to do this. So here's 1, here's 2. 2 is 8/4. So negative 7/4 is here. And then let's see, it's going to be bracket. And then less than or equal, so shading this way. So let's label that negative 7/4. Set of all the x's, where x is less than or equal, negative 7/4. Negative infinity to negative 7/4. Start by distributing. 5x minus 10 is less than 3x plus 3 plus 2x. Let's see, we have like terms on the right side of the inequality. Oh, this is interesting. Look what happens here. This is a special case because my x's actually cancel. So that means I'm dealing with something interesting. So I have a special case. So then I have to look at the resulting inequality here and say, well, when is this statement true? In other words, for which values is negative 10 less than 3? Well, isn't this always true? Negative 10 is always less than 3. So if I have a statement that's always true, that's true for all real numbers, right? So I would say the solution is actually all real numbers. Any number would satisfy that inequality, since that is always true. Here are a couple of these compound inequalities. So I solve these the same way. I just have to do the same thing to all 3 parts instead of just 2. So like my goal is to isolate the x, right? Move this up actually. So I guess the first thing I would do would be add 1. I have to add that 1 to all 3 parts. So I have negative 14 less than or equal to 2x less than 38. Then I need to divide by 2. I have to divide all 3 parts. then I can write out my solution. Let's see, I might have to kind of scale this. Let's see. Let's call this 0. Oh, actually, let's not. I need a negative in there. So let's just kind of be general. So let's call this, say, -7 and this 19. Okay, so it's not going to be to scale. That's okay. Number's a little big. So I'll shade between. Let's see. Both of those get... looks like I have a typo. So I'm looking here at the inequalities to decide if I have brackets or parentheses, but be careful, look here. Looks like I made a mistake, didn't I? This one should be less than. So that guy gets a parentheses. Okay. And there's my interval. So one more time with these notations. Number line, set builder, and interval. 3 different ways of writing the solution depending on what the problem asks for. Okay, let's try another compound inequality. So how about subtract this 5? Okay, now I need to get rid of that -1/3 there. So what if I multiply all 3 parts here by -3? Now don't forget, I'm multiplying by a negative. So if I multiply an inequality by a negative, I have to flip the inequality. Okay, so where does that land me? So negative and negative, positive 18, greater than, let's see, the -3's cancel, x greater than 12. So that's the same as saying 12 is less than x is less than 18. So now I can write out the solutions, the solution in 3 different notations. So let me kind of scale again. I'll call this 12 and this 18. Shade in the middle. Both of these are open parentheses. Set builder, set of all x's, where 12 is less than x is less than 18. Interval notation, 12 to 18. To get an A in a class, I must earn at least 540 points. So what does that mean? So I must earn at least or greater than 540 points. So far, my test grades are 85, 83, 90, and 96. Let's see, 85, 83, 90, and 96. And the final counts for 2 test grades. what grade do I need on the final to get an A? So what is, before I finish the inequality here, remember I should write out my variable. So x is the number of points I need on the final to get my A. Okay, so let's see. What do I still need to fill in? Let me read through this one more time. So far, I have my test grades. The grade on the final, so X counts for 2 test grades. So let's see if this makes sense. So I have my 4 test grades plus 2 times the grade I get on the final, and that has to be more than 540 points. Okay, now I just need to solve my inequality for my variable. So let's see, I start combining, what is that? 168, 186, $354. Subtract. So let's see, 6. Let's see, 13 minus 5, 7. 13 minus 5 is 8, isn't it? So you could probably use a calculator here. Let's say I get 186. And then divide by 2, excuse me. So what is that? 93? So I have to answer the question. So what grade do I need on the final? Looks like a T, doesn't it? What grade do I need on the final to get an A? So I need at least a 93 on the final.